Hello everyone, I'm Seema. Today we have Diane from Autodesk with us. Welcome Diane.
Hi Seema, thank you, glad to be here.
Can you tell us a little bit more about Autodesk and your use case?
Yeah, Autodesk provides design and make software to innovators for them to achieve the new possible.
Okay.
For our use case, this is our data pipeline, and we have data coming into S3 in the volume of 13 terabytes daily.
Okay.
Once the data comes in, we trigger an event to simple notification service or SNS, which then triggers invocations to the lambdas that we have. So our lambdas do a lot of processing, cleansing, the enrichment of the data. And once those are done, it actually writes metadata into DynamoDB. And that metadata is actually read by Elastic Container Service or ECS in order for it to do batch processing.
Okay.
And then once ECS processing is done, it actually writes data back into S3 for our end users to be able to use that data.
Okay. What kind of batch processing does ECS does?
Yeah, sure. So ECS is actually async RESTful Web API service, and what it does is that it batches altogether the output JSONs from the Lambda into batch Parquet format for read efficiency.
Okay, sure. And how about SNS? So are there any other functionalities that you're trying to achieve?
Yeah, for SNS actually, we use it in two ways. One is this notification, and the other way is these lambdas, right? They actually have an internal retry mechanism.
Okay.
And once that retry mechanism, if the processing still fails, we actually send an event to SNS, which then triggers another lambda to copy that erroneous file back into S3 for us to investigate what's going on with that file.
Okay. So your data volume is always 13 terabyte?
That's an interesting question. The data volume, it doesn't come into a stream like this. It actually has peaks and troughs like that. So at one point in time, it can be as low as 1 terabyte. And at its peak, it can actually go up to 13 terabytes. In fact, one of the challenges that we were trying to solve with this serverless architecture is because of this. In our traditional Spark-based processing, in order for us to be able to process the peak data volume, we have to provision memory in order to be able to handle this. But in cases where the data volume is at its low, it becomes very inefficient and very costly. That's first. And the second one actually is that as the data volume increases, this is the data volume right now, but it keeps growing and growing. So our Spark-based data pipelines are starting to struggle in processing that data. So the data processing becomes longer and longer, and our users have to end up waiting a longer time before data becomes available. Whereas with this new event-based architecture, data actually is provided to our users in near real time at a fraction of the cost.
Okay, sure. And so what are some of the challenges or learnings that you have from this architecture and you can share with us?
Sure. This is actually an interesting use case to be using Lambda for such a huge amount of data volume. As with Lambda, it is not traditionally used for big data processing like this, but since it's an interesting use case, we just have to be mindful and smart about how we're using Lambda, and the application code that we have should be very efficient in processing such huge amounts of data volume. That's the first one. And the second challenge actually that we met, this is not the original architecture. Initially, we were using S3 to read and write the metadata. However, when we were doing that, we found that the lambdas were taking around 15 minutes to process and oftentimes timing out. And when we dug deeper, we found out that it was because of S3 is not a service that is catered to low latency, high throughput operations. So we actually did some research and found that we had to replace it with a service that is fit for that purpose, which is DynamoDB. DynamoDB is a service that handles throughput and latency very well. And once we replaced that service, we actually bring down our processing time from 15 minutes down to 20 seconds.
Okay. Are there any enhancements that you're planning for the architecture?
Yeah, one enhancement is actually this. Right now, we plan to use managed SQS for better efficiency in handling the data and handling the notifications. That's one of the key changes to the architecture that we want to make in the real near future.
Okay, awesome. So I enjoyed this conversation. Hope you did enjoy as well. Thank you so much. This is my architecture.